Hi, my name is N. Palani Karthik. I am part of Intel Unnati Industrial Training 2024. My problem statement is Intel Products Sentimental Analysis from Online Reviews. My problem statement number is 11. So we'll be moving ahead to the first part of the project, which is data collection. So as you can see on the pie chart, it shows you the percentage of reviews which are collected from each site. So I have collected reviews from sites such as Amazon, Flipkart, Google Reviews, PC, Part Picker, etc. And on the tech, only the customer reviews which are present in the bottom of the web page. Same for PC Mag and Tom Hardware. So the total reviews collected were around 20,000 data points, and these data were collected through Python libraries like Beautiful Soup, and I've used pre-built scrapers like Octoparse, ParseHub, and Bardeen AI, and I've also used Chrome extensions which are instant data scraper and etc. So mostly I've used pre-built scrapers like Bardeen AI and Octoparse, and Chrome extensions which are instant data scraper, which constitute about 80% of what I've scraped, and the rest, very few, goes to the Python libraries. So now I'll be talking about the second part of the project, which is data pre-processing, which involves two things. One is cleaning and next is text processing. So in data cleaning, first we remove all the duplicates. So the data set contains columns such as review text, short review, and reviewer name and reviewer date, etc. So first we remove the rows which have redundant data, like if the review text are matching as same to same, then we delete it, and then we handle the missing values. Suppose if the review has nan values, then we check in the short review column whether any value is present and we replace it. Suppose if no data is present in both review and short review, then we replace it with a string, empty string. And another common problem which we face is the language. So the data is given reviews in many languages like Spanish, Chinese, Japanese. So we convert all these reviews into English language so that it will be easier for text processing. So we have used Google Translate function, which easily translates all these. And next is text pre-processing. So for text processing, we use three things. One is tokenization, in which the text is broken into smaller units and only the important words are taken. And next is stemming and lemmatization. So from tokenization, we try to reduce the words which are unnecessary, and then we use stop word removal, which also removes the words like the, is, and. So these steps help in removing the dimensionality of the text data and improve model's ability to generalize. So now I'll be discussing about the implementation in detail. So first, we have already discussed that from e-commerce website we use web scrapers and we collect the data. So after collecting the data, we do data pre-processing such as handling null values, converting all reviews to English, and handling duplicates. So after data pre-processing, we have a data set in which there are irregularities in the number of positive, negative, and neutral. Because while fine-tuning an LLM, we need to give equal number of positive, negative, or neutral. Otherwise, the LLM will become a over or underfitting model. So to handle the over and underfitting condition, to avoid those, so we downsample and upsample the sample which is collected from data pre-processing, and we store it in the Hugging Face in this link, Intel Unnati. If you go to this link in Hugging Face, you will get the fine tuning data set which is used to fine tune the model, and then we fine tune the model and we load the model in Olama for fast local use, which is an open source software. So it is used because usually the without Olama it takes a lot of time for running, and there is maximum RAM utilization which crashes the system. So we use Olama, and then using the pre-trained model we test the data. So we evaluate the data from text from test.xlxx. This is test. So after testing it, we do the evaluation matrix on this. So we calculate how much precision, accuracy, F1 score, and recall is there, and we Also divide the data set into test and remaining dot xlsx, which is fed and which is combined to give conclusions updated dot xlsx. So this entire thing is trained using the model which we have fine-tuned over here for the entire 20,000 reviews, so that we get an overview of how many reviews are there for the entire data which we have collected. And then we draw the conclusions from the graph, and we take insights from it. So I want to mention again that for fine tuning we have used the model which has exactly 33 percentage of positive, negative, neutral, so that it has no underfitting or overfitting condition. And while drawing conclusions, we have used all the 20,000 points from the model which is trained using this uh, data set which has equal number of positive, negative, and neutral commands. So we can visit this website which has the entire details in detail. Before moving into the actual implementation, I would like to give an overview of the dataset uh, details. So the dataset which we have collected contains of these columns. So the columns are reviewer name, stars, short review, review date, reviewer profile link, review link, product name, helpful, whether the comment is helpful or not, generation of the Intel product, site from which it is collected, name which is extracted from the product name. So these are the columns which we have extracted from the e-commerce site, and the data is stored in this manner in a table format. So all the 20,000 records are stored in the same format, and we will try to generate predicted sentiment and actual sentiment, uh, which will be added in the actual implementation. So now we'll be moving on to the actual implementation. So this is my GitHub repository, and we once we click on code, we will see this pop-up menu. We can copy this link and put it in the terminal, and we can put git clone the link which is there over here. And once you run this command, you will see all these files popping up, and your screen should look like this after running the command git clone. So after clicking on the first one, which is model with main script folder, which contains all the data sets and the main ip by nb file. So this file can be run using either Jupyter Notebook or Anaconda or Google Colabs. So I have used Google Colabs because we can use the free GPU which is in Google Colabs. So we load this file in Google Colab. So I've already loaded it, you can see over here. So after loading it, so make sure in the working directory these three files are there: the site reviews, Intel, conclusions updated, test actual reviews, which are also present in the same folder. One model with main script, you can see these three files, this one and this one, these three folders which must be there in the working directory before running all the files, so that you will have smooth running of the Jupyter file. So I recommend first not going from the first of the script, first go from model building, because the model building requires a specific version of the pi arrow which is different. Once you run import pandas and some commands over here, it changes the settings of the pi arrow. So when you start the file, first I recommend you to run the model building, which is over here, which is just the next section of the first one, which is model building. So I've already run it, so I've installed all the required libraries, LangChain, I've imported Olama, and then I've installed Accelerate, Peft, transformers, and bits and bytes for converting into bytes. So I've loaded the model. So you can see I have loaded my model, my data set, which is there in Hugging Face as Palkar Intel Unnati. So this is created by me in Hugging Face. You can go to Hugging Face and look at this model, and this is the base model, which is the Llama model, which is been fine tuned as Llama 3. So you can see we have loaded the data set, and the data set has been loaded, and we are fine tuning it. So we have quantized it as 4-bit, and then we load the model. So this is a 9 GB model. So make sure you have the relevant configuration, and we tokenize the model and we make the padding as right, and then we choose the training parameters. We choose the learning rate as 2e to the power minus 4 and the logging steps as 25. So we load it in the trainer, and the model, we save the model under llama 3, which I have mentioned above, llama 3. So using this model, we have called the model over here, and I have just made a sample response. For the question is, what are the benefits of using llama 3 for natural language processing? So you can notice after running this cell, we get this as the output for the question. It shows that Llama 3 is designed to be fast, efficient, and easy to use. So it shows that the model is working and it is saved under the Llama 3. Now, after we run the cell, we move to the starting of the uh, Jupyter file, and we check whether the GPU is installed, and then we in this Excel file there contains all the reviews in different sheets, so we merge all these files and we perform exploratory data analysis for handling duplicate null values and to convert all the reviews to English. So after that, we do the model data building where we split the data into test and remaining Excel files. So and we save it in the directory with these names, remaining and test Excel files. So after that, we have run the fine tuning train data set, which I have already shown above, due to which the Llama 3 model is saved above. So we are skipping to the next part, which is to run this command, which loads the terminal in the collab. After typing this, we type these two commented lines over here. So after running these two, it comes downloading Olama, and it downloads, and then after that it pulls the manifest. So it's pulling the manifest for you, and it will come manifest is pulled. So this takes a little time, and it takes around 2 minutes. So after that it comes writing manifest and it comes success. So after that, this is the model which calls the Olama. After that, I have run this test xlx file to just show you how it runs. So while running this, it shows in the terminal whether the request is being passed to Olama or not. So on being passed to Olama, it will come for each request. It will come post API generate, and it will come the seconds that it took to generate the response. So it can see 1 second, 1 second, 3 seconds, 1 second for each record. It took the reviews from the review column and it passed to the model, and it categorized it as positive, negative, or neutral, and it has updated in the column predicted sentiment. So you can see it keeps on going for the next and next and next until the 6,000, around 16,000 records are there. So it does for all of them. So it takes around 6 hours or more. So make sure you have a dedicated GPU installed in your laptop so that you can use that also. So for now, it will take a lot of time. So I'm skipping to the next part, which is this. So I'm just going to pause this. So I have run the cell already. I have already run it, and I have got this as my output. So you can see your sentiment will come as positive or negative or neutral based on the reviews after running the cell in the terminal. So this is the predicted sentiment from the model. So similarly, we'll do for the remaining Excel sheet for combining it with the train Excel sheet so that we can make analysis on the entire data set. But we have trained the fine-tuned the model only using the data set which has equal number of positive, negative, neutral. But now we are combining it so that we'll get more broad overview of the data set which we have collected, around 20,000 data points. So we similarly for the remaining Excel sheet, we have uh, doing the same thing. So after running that, we will get the same thing for this data set also. We'll get the predicted sentiment, whether it's negative, positive, or neutral. So later, I have used the Excel sheet and updated it to Excel actual reviews, in which it has in which it has an extra column called the actual sentiment, in which it is manually entered for making for calculating the correct accuracy. So we are calculating the accuracy using this Excel sheet, and we will calculate the precision, recall, F1, and even draw the confusion matrix. So you can see this is the evaluation metrics which we have got for this model, which is 91 percentage, 93 percentage, and F1 score is 92 percentage. So we have also calculated the confusion matrix, and it is given over here. So you can take a look of it. And finally, we'll draw the conclusions from the from which the model has predicted whether the reviews are positive, negative, or neutral. So first, this is the bar chart of the data which we have used for fine tuning. So it is 33 percentage each, so that the model is not a does not give fully positive or negative or neutral in a more basis. So it's all equally shared. So it is a proper model and it does not has any overfitting or underfitting conditions. So the next plot we will see the percentage of reviews from each site. We can see that more reviews are there in Best Buy, Amazon, XCOM, Anand Tech, and PC Part Picker, and respectively for others. So from this, we can conclude that the customer base is more interactive for Best Buy, Amazon, KCOM, and all these sites in comparison to these sites like New EGG or Mind Factory. So we can say that these are more interactive and the customer base is highly interactive. So we go to the next plot in which we have compared the sentiment distribution for each site. So we can see that for Anand Tech, the negative reviews are more come very high. So we can say that the customer reviews in this site is highly critical and less positive. So this is highly critical site. And similarly for Pegasus Electronics, we about 15%, and for PC Mag about 16%, which is also considerably high. So we can say for Pegasus, PC Mag, and especially for Anand Tech, the negative reviews are high and the customers are highly critical. And from Best Buy and other sites, you can see about more than 80 percentage the customer reviews are positive. And next, so we go to the next graph, which is the similar graph actually. Next, we'll see the sentiment distribution by generation. So for each generation, these are the number of reviews and the count of the number of reviews. So you can see that the number of reviews for the 10, 11, and 14 are less, because for 10, 11 the customer base wasn't that active. So you can see a sudden rise in the commands in 12 and 13. This is due to the increase in the engagement of the customer reviews in the e-commerce site. And in 14 you can see that the customer reviews are less, because 14 is the recently launched, so there are relatively less comments in the customer side. So it will continue to increase as the time forwards for generation 14. So I've given the same chart in the pie chart. So you can see that the negative reviews has remained constant for generation 10 and 11. As you go on to 12 and 13, it's almost the same. But for 14, you can see a considerable increase in the negative reviews. This is because the even though the reviews for generation 14 is less, the customer base have been more educated and more informative, and they have been giving highly critical reviews in comparison to the before generations. So we can conclude that the customers have become little more aware technologically and are being commenting properly. So this is the this is the end of the implementation and the conclusions which we have made. We have finished the implementation of the Jupyter file, and using the model, I have created a chatbot and a web page application. So in the main page, you can see there's a navigation bar of with my details, and we have used the Llama 2 7 billion parameters. And in the main page I have attached all the images and the outputs which we have got, and including the evaluation metrics. So it contains all the images of the output which we have got. So we can, if we click on the chat page, if you go to the chat page, we can type the review and it will classify the review as positive, negative, of neutral only, and it will give the reason why it has labeled it as that. So the advantage of the LLM is that um, you can ask, say, make the LLM to think as it from the Intel side and make the reviews and label the reviews accordingly. Suppose if I type good product, so it labels it according as positive, negative, or neutral, and it also mentions the reason why. So similarly, if I click here to go to main page, it goes to the main page. So you, if you want to run this file locally, you can click over here, which contains the GitHub repository. To run this file, you can just use Streamlit to run the file name. So I will like to show you how and where the things are saved. So the output images is the folder which contains all the images which we have uh, downloaded and which we have taken conclusions from. So the llama 3, this is the folder where all the where the model is saved. So the llama 3 contains all the files like safe tensors and the tokens. So you can see the adapter model is saved in a compressed zip file, so that it is made adaptable for the GitHub, because maximum only 100 MBs are allowed. So you can extract it and use it if required. And similarly, the this third folder, which is the Intel Karthik website, is the GitHub repository of the website. It's a clone of the repository. The actual repository can be accessed through the website which I have shown above. And this is the main folder which contains the files and the main Jupyter file. And if it has a readme which mentions in text files what to do. If not, you can look at the video which is mentioned in the video link. The video link is a text file which contains the link, so you can click on it. And this is the report PDF which contains the report. So if I open the report, it is a 20-page document which contains the full information about the implementation in written format in 20 pages. So this is my phone number, email, and GitHub and website link. So my fine tuning data set and my full data set Hugging Face links are also available over here. This is the full implementation. Thank you.